Hi everyone, welcome to Irfan CFPS YouTube channel. If this is the first time you are visiting my channel, please make sure to hit the subscription button and notification icon to get the updates related to the firefighting and fire alarm systems. As you already know, we have started a new course on Certified Fire Protection Specialist, so that it will be helpful for you to pass the CFPS examination. So we are going to consider the fire protection handbooks which are recommended by National Fire Protection Association. So in last session we have dealt with section 16 of that fire protection handbook, and in today's session we shall go through section 2, which is basics of fire and fire science. So basically from this section there will be 10% of the questions will come in your CFPS examination. So this section is also an important section for you, and also it is little bit easier than section 16, so you can easily understand the topics of this section. So as the name suggests, this section is related to the basics of fire and fire science, which means physics and chemistry of fire. So in section 2 there are subsections. Just I will name it: physics and chemistry of fire, physics of fire configuration, flammability hazard of materials, dynamics of compartment fire growth, basics of fire containment, fundamentals of fire detection, theory of fire extinguishment and explosions. So if you go through this, the chapter 1 refers to physics and chemistry of fire. So it deals with the physical structure of the flame, chemistry of flame reactions, and also the fire characteristics. Chapter 2 refers to the physics of fire configuration. Chapter 3 related to the flammability hazard of materials. In this there are various test methods mentioned. So chapter 4 related to the dynamics of compartment fire growth. It is to provide a basic understand of fire growth in enclosed spaces. Chapter 5 defines the basics of fire containment, which discuss the furnace test methodologies. We will go through in detail once we reach this chapter. Chapter 6 will be fundamentals of fire detection, which covers simplified review of the fire development in the context of detection, and also covers fire signature and detectable phenomena. And chapter 7 refers to theory of fire extinguishment, which covers various physical mechanisms for affecting the combustion process with water and other agents. Chapter 8 is the final chapter of this section 2, which is termed as explosions. It covers various types of explosions, energies released, peak pressures produced, and resulting blast waves. I have highlighted some of the points which are most important, so you can make a note on this. Since I am not going to cover the whole section 2, since it will take a lot of time due to time limitations, I am only going to cover the important points that will be helpful for your CFPS examination. So section 2 chapter 1 is related to the physics and chemistry of fire. Just a minute. Okay, so here on right hand side the contents of this chapter are mentioned. So just you need to have an idea what does this chapter 1 cover. So you can just go through this chapter of contents, and also key terms also included here. So first topic will be heat transfer, and in heat transfer I have highlighted some of the points. Heat transfer governs all aspects of fire, from ignition through to the fully developed fire and beyond to the failure of structural elements. So here we will see the basic terms which are used, including the concept of temperature itself. So temperature units. See, you might get a question from the temperature units or temperature measurement in your examination. So temperature units, as you all know, Celsius, Kelvin, Fahrenheit. You can just go through these things once you have a time. So I just highlighted these points just to make sure that you should not miss any of these topics. So temperature units cover Celsius, Kelvin, Fahrenheit and Rankine. Fahrenheit and Rankine degrees are not approved SI units and their use is greatly discouraged. Temperature measurement, it consists of few terms such as liquid expansion thermometers, bimetallic thermometers, thermocouples, pyrometers. Pyrometers measure the intensity of radiation from a hot object. Heat units, we have joule and watt, okay, and also calorie, British thermal unit. From this also you might get a question. These are very simple, just you go through once, you will get an idea. So for example, in your examination, if they ask about joule, if you see this word in your exam question, then you just come to section 2 and chapter 1, you will find this joule and you will find the answer here itself. For example, what will be 1 kilojoule is equal to dash joules. So you can refer this particular paragraph, you will get the answer. Or you have 1 watt equal to how many joules per second, something like that they might ask. Or they might ask Kelvin is the same size as the Celsius degree, but the 0 on the Kelvin scale is dash, something like that they might ask. So many things are there, just you go through. And in specific heat, water has a specific heat of 4200 joule per kg dot Kelvin. Okay, latent heat and heat of gasification, this is also an important topic, you just need to go through thoroughly. A substance absorbs heat when it is converted from a solid to a liquid or from a liquid to a gas. This thermal energy is called latent heat. This is very important point. Latent heat is the quantity of heat absorbed by a substance passing between liquid and gaseous phases. Latent heats are measured in joules per unit mass. So they might ask the unit of latent heat as well. So the term heat of gasification is used to describe the amount of energy that is required to produce a unit mass of flammable vapor from a combustible solid that is initially at ambient temperature. Density, you can see the definitions here: specific gravity, gas specific gravity, buoyancy. Okay, so these are the topics related to the latent heat and heat of gasification. Heat transfer mechanisms are there, we already discussed before. There are three basic mechanisms of heat transfer, namely conduction, convection and radiation. These equations also very important. You can just go through these equations. I have highlighted one equation which is Stephen-Boltzmann's constant. This formula is for Stephen-Boltzmann constant. This might ask in your examination. Conduction, the definition states heat transfer through a solid from a heated surface to the interior of the solid is the process called conduction. Conductance depends upon the thermal conductivity, the cross-sectional area normal to the flow path and the length of the flow path. Okay, and also I have highlighted the flux. Just go through the flux definition as well. And here we have Biot number, lumped thermal capacity. Just go through those things. And apart from that, we have convection. Convection involves the transfer of heat by a circulating fluid, either a gas or a liquid. These are basic concepts of science. You can easily go through these things. And we already learned in our childhood about Boyle's law, Charles' law and so on. So ideal gas law, all these are also very important for this examination. We have three formulas for Reynolds number, Re equal to, there is one formula, okay, and Prandtl number and Grashof. So these three are very important formulas, they might ask in the examination. Radiation, visible light consists of wavelengths between 0.4 into 10 power minus 6 to 0.7 into 10 power minus 6 meter, which correspond to the blue and red ends of the visible spectrum respectively, whereas thermal radiation occurs principally in the infrared region. So this is an important point. Apart from this, we have here regarding the black surface and the absorptivity, the definitions just will read for you. The absorptivity of the surface is simply the fraction of the incident radiant heat that is absorbed by the surface. A surface with an absorptivity of 1 is called a black surface, and you have the formula for Stephen Boltzmann law here. Once again, just go through these things. Apart from that, we have flame structure. The following are the two types of flame that we have to consider: pre-mixed flame and diffusion flame. The pre-mixed flame, in which fuel and air are intimately mixed before ignition. The diffusion flame, in which fuel and air are initially separate and burn in the region in which they mix. They have just shown the figure of the pre-mixed flame and the diffusion flame. So basically, I am just covering the most important points which are helpful for your examination. However, you need to go through the complete section in detail in order to pass the CFPS examination. Here we have fire chemistry in chapter 1 itself. So they have mentioned the basic definition. This is also an important topic, the periodic table. This also we learned in our childhood, the periodic table. They might ask related to the periodic table one question, and you have the definitions of atoms, atomic number of an element, atomic weight of an element, elements, what does it called, and also the chemical element. This is also an important table. They might ask the symbol for cesium, for example CS, and the atomic number 55, atomic weight 132.91. so they might ask any question in the examination. However, this is also an important table. You just need to identify, initially read the question and identify the keyword mentioned in the question, and you need to have an idea where you can find in the handbook. So it will be easy. Don't memorize any answers, just go through the fire protection handbook. Since it is an open book examination, you will have the handbook with you, the hard copy. So just check the question, identify the keyword, come back to the section and in the fire protection handbook, and refer the answer or check for the answer in that particular section. So you will get the answer easily. And practice makes man perfect. So practice is very, very important. You need to take some CFPS practice exam questions from somewhere and just practice. So once you practice chapter wise or section wise, you will be very much familiar where you need to find out the the keywords or the topics in the fire protection handbook. So just we will continue our class. There are some more definitions like isotope, molecule, chemical formula, molecular weight of the compound, mole, chemical reaction. I think you can understand from this that this section 2 deals with the basics and the definitions of the physics and chemistry topics. Okay, and you have stoichiometry. A stoichiometry mixture of fuel and air is one in which there is an exact equivalence of fuel and oxygen, so that after combustion all fuel has been consumed and no oxygen is left. Heat of reaction, we have exothermic and endothermic reaction. So the heat of a chemical reaction is the energy that is absorbed or released when that reaction takes place. Exothermic reactions release energy when they occur, whereas energy is absorbed when an endothermic reaction takes place. This is also an important point. So ignition, we have chemical reactions in flames. How does it occurs? They have just mentioned. We have some table also here, the reaction mechanism for the oxidation of methane. So in chapter 1 we have only points related to the definitions of physics and chemistry, and in summary just I will go through for your easy understanding. Fire is a complex phenomenon. To gain an understanding of fire behavior, it is necessary to have at least a basic knowledge of a range of subjects including chemistry, physics, heat and mass transfer, and fluid dynamics. In this chapter, some of the chemistry and physics required to explain the most important aspects of fire behavior are presented. The relevant terminology is explained in detail and an attempt has been made to place the individual terms in context. It is important to use technology that is consistent with scientific and engineering disciplines. So from this paragraph, I believe you have got a good understanding what this particular chapter 1 covers. So just go through this summary, you will get an idea. So now we will jump into chapter 2. In section 2, physics of fire configuration. Here they are defining the characteristics of fires. So just we'll have an idea. Just I'll read for you. The jet spray configuration is applicable to gaseous and liquid fuels, and the pole configuration pertains both to liquid fuels and solid combustible surfaces, including those that melt rather than char. So basically the contents of these chapters are mentioned on your right hand side. What does it covers? We have a heading flammable gas jets and liquid sprays, pools or horizontal upward facing surfaces. You might get a question from this particular topic as well in your examination. Flammable liquid fires. Pool fire flames are strongly affected by the amount of freeboard. You just go through these topics. Just I have highlighted some of the important points. Fires on solid surfaces, heat flow related to this pools. Okay, for flammable liquid fires, fire growth also, and you have walls or vertical surfaces, general behavior of flames on walls or vertical surfaces, heat flow and fire growth related to this particular topic. Ceiling or horizontal downward facing surfaces, flames from fire plume below unobstructed combustible ceiling. All these topics are covered under physics of fire configuration. Ignition at surface or surface of combustible ceiling, and flames. See, this might be you might get one question from this particular topic as well. Just go through inclined material surfaces, flame attachment and heat flow. The following conclusions can be drawn from the experimental correlation in figure 2.2.4 regarding the effect of angle of inclination on fire characteristics. Flames attached to downward facing burning surfaces inclined more than 12 degrees from horizontal, increasing flame spread rates. If the downward facing burning surface is inclined less than 12 degrees from horizontal, flames detach and thicken to form the characteristic cellular pattern of a ceiling fire. Near this 12 degrees transition, the formation of a cellular ceiling fire leads to increased heat transfer rates. So we have some other topics as well you need to go through. So combustible ducts, and in summary what they have given, just we'll go through for a good understanding. Defining characteristics of fire in different geometric configurations have been discussed in terms of flame behavior, heat flow and fire growth. The potential impact of a fire on the local environment is strongly dependent on the configuration and scale of the combustible surfaces that become involved. Generally, pool or horizontal upward facing surface fires are associated with the lowest rates of flame spread, the highest heat flux from the flame envelope, and the highest burning rates. Wall or vertical surface fires are associated with the highest rates of upward flame spread and somewhat lower flame heat fluxes and burning rates than for pool fires of the same scale. Ceiling or horizontal downward facing surface fires are characterized by thick moving cellular flames. Small changes in the inclination of both upward face and downward facing surfaces can result in abrupt changes in flame behavior and the heat flux environment. Finally, configurations that represent combinations of the preceding single combustible surfaces have distinctive flame behavior and heat transfer characteristics that are important in many practical fire scenarios. Basically, this chapter is dealing with the flame behavior and fire growth and heat flow. So now we'll move ahead with chapter 3, flammability hazard of materials. we have different topics covered here, like HRR test methods, heat release rate. These are the two most important topics in this particular chapter. So you just go through the definitions of heat flux, what does it mean, smoldering, pyrolysis, and heat of gasification. We already checked the heat of gasification. Here also we have the definition. The energy required to convert a solid material into a vapor through pyrolysis is termed as the heat of gasification. Important point. Physical changes during pyrolysis, char, we already got this particular term in previous section. Here we have the definition, you can just go through. We have intumescence, melting, ignitability, and this is an important table. You just look on this. Thermal properties of selected materials. Material copper, we have thermal conductivity 387, density 8940, heat capacity 380. So this is an important table. Just go through this. Maybe you might get a question in your examination. So thermal inertia is also an important topic. What they say, the thermal inertia of material is a direct product of three physical properties: thermal conductivity, density, and heat capacity. This is also an important point you need to remember. I'm not going into the detailed concept of all these particular topics, since we have total 104 pages in this section 2. Just I am going to cover only the highlighted points for for easy identification and understanding. Also I have highlighted these points for your easy review. Okay, so if you want to understand the detailed terminologies and so on, you just have to look for some other videos of mine where you will get all the answers with detailed concepts. So we are going since this is an intensive course, I am covering the only most important points which are required for the examination. Also, you no need to memorize anything, as I already told you. You just need to identify the keywords in the question, and since this is an open book examination, just open the handbook and identify the identify the topic which you are looking for. So practice is very, very important. I stress practice is very important. You have ignition test methods, and also heat release rate. Heat release rate is probably the most important quantity used to characterize the flammability hazard represented by a given material. It is a measure of the rate at which a burning item releases chemical energy and is usually expressed as heat released per unit exposed surface area of a burning material or specimen. This is the unit they mentioned here. So we have flame heat transfer. Typically materials are tested in laboratory calorimeters at an imposed heat flux of 50 to 75 kilowatt per square meter, which is a flux known to occur in many types of real scale fires. Under such conditions, measured heat release rates less than 50 to 100 kilowatt per meter square often indicate a relatively low flammability hazard. The heat transfer from real scale flames is primarily due to thermal radiation. HRR test methods, this is also an important topic. Just you need to go through this. Measurement of heat release rate, laboratory scale calorimeters, OSU apparatus, the Ohio State University calorimeter apparatus, fire propagation apparatus, cone calorimeter. The cone calorimeter is probably the most versatile oxygen consumption method for measuring heat release. Okay, so this is an important point. Apart from that, you have a single burning item test, large scale calorimeters, room corner fire test for surface lining. So basically this is dealing with the testing methods. You have furniture calorimeters, ICAL. The ICAL is an intermediate scale calorimeter that has been designed to measure heat release rate, mass loss rates, and visible smoke development from a 1 meter by 1 meter vertically oriented non-melting material under well ventilated conditions. Flame propagation propensity. Since the topic itself related to the flames flammability, so we have various test methods here. Flame spread test methods like tunnel test. The Steiner tunnel test is one of the earliest test methods developed for assessing the flammability hazard of materials through measurement of flame spread. I think you got the point now. So radiant panel test, lift apparatus are also various tests. Radiant panel flooring test, vertical burn test, parallel panel test, large scale corner room and fasket test. Smoke yield. Smoke has long been identified as the most significant hazard to people during fire. So we have a smoke yield. So for smoke yield also there are test methods. Smoke chamber test, guide for measurement of fire gases, extinguishability. And now we are coming back to the summary for this chapter 3. So basically this chapter is referring to the test methods for heat release rate, flammability and smoke yield. So I think you understand now. Just we will go through the summary. By definition, any material capable of burning with a flame is considered flammable, but the flammability hazard of a material in a specific fire scenarios is not easily quantified. Different aspects of flammability hazard can be defined or categorized, and for each such category, a test method is available to measure the magnitude of a material characteristic that can be used to evaluate, if not quantify, flammability hazard. These different aspects of flammability include type of response to heat flux, ease of ignition, generation of heat and smoke, extent of flame spread and ease of extinguishment. The flammability of a material is dependent on many parameters such as its chemical composition, physical properties, geometric configuration and combustion products. As a result, flammability is really a characterization of multiple fire hazards. There is no single measure that will adequately describe a material's performance in a real fire scenario. Given the large number of parameters that play a role in determining flammability hazard, it is important to use a variety of flammability test methods and models in order to have a more reliable and accurate assessment applicable to realistic fire scenarios. So we have gone through the 3 chapters. Now we shall move ahead with chapter 4, dynamics of compartment fire growth. Here there are 2 general types of fire, pool fire and compartment fire. This chapter also refers to the fire growth. The content fire growth is an important concept for your examination. Classification of fire, effects of compartment boundaries on fire. So fire growth we have so many things: heat release rate, apart from that fuel loading, classification of fire. This is an important topic. You might expect a question in your CFPS examination. So classifications of fire. Fires have been characterized in 4 general ways: type of combustion process, growth rate, ventilation and fire stage. Okay, classification by types of combustion process. Perhaps the simplest definition of a fire classification would be to divide the fire into 3 regimes: pre-combustion, smoldering combustion and flaming combustion. Smoldering is defined as glowing combustion on the fuel surface and may or may not be related in any way to the oxygen content in the vicinity of the smoldering process. Classification by rate of growth. This is also an important topic. Fires may also be classified on the basis of fire growth rate. Fire growth can be either positive or negative. As you can see on on this graph, categories of fire growth based on fire growth rate. You have heat release rate in kilowatts on y-axis and time in seconds on x-axis. See, you can see this growing fire and then steady state fire and decay. So classification on the basis of ventilation, just go through, and this classification by fire stage. So you have classifications of fire. In that you have sub topics like classification by type of combustion process, classification by rate of growth, and now classification by Fire stage, also we have seen classification on the basis of ventilation. So this also an important topic, like classification by fire stage. 4 stages are commonly used as follows: incipient fire, fire growth, steady state, fire decay. All the definitions are here. Incipient fire refers to that stage when there is smoldering but insufficient flaming for established burning. The fire growth stage represents increasing fire growth with respect to heat release over time. During this stage, the fire would be considered fuel controlled. When the heat release rate is basically constant, the fire is considered to be in the steady state stage. In the fire decay stage, the heat release rate is decreasing over time. So this is an important paragraph you have to go through. Maybe you might expect a question from this as well. Effects of compartment boundaries on fire. Fire in the open. What is the process, entrainment process? You just go through, you will get an idea. Okay, and apart from that, you have fire in a compartment. Also you have the definition of flashover here, full room involvement, what does it states, and finally we are coming back to the summary. So basically classifications of fire is an important topic in this particular section. So summary states the discussion was presented to provide the reader with an overview of the processes involved in fire growth and spread in and beyond the compartment. For additional information, the reader is encouraged to study the equations and relationship discussed elsewhere in this handbook. So we will go through chapter 5 quickly. Basics of fire containment. Here we have some of the topics such as rate of fire growth, containment, emergency egress. These are the 3 following types of passive fire protection measures. And you have some terminology or general terms such as active fire protection, code equivalency, compartmentation, fire resistance rating, heat flux. The rate of heat transferred per unit area perpendicular to the direction of heat flow is referred to as heat flux. Important point. Model building code, passive fire protection, performance based code, prescriptive code, wildland vegetation. See, in your examination they might ask any of the definitions. Since it is a multiple choice examination, you can easily identify the answers. So fire resistance. Flashover is a transition phase in the development of a compartment fire in which surfaces exposed to thermal radiation reach ignition temperature more or less simultaneously, and fire spreads rapidly throughout the space, resulting in full room involvement or total involvement of the compartment or enclosed space. Just go through the flashover concept as well for your examination. Here we have the definition of load endpoint criteria, standard fire resistance furnace tests, they say ASTM test standards, other fire resistance furnace test standards. So many things are there, and you have to go through all these things. Here we have summary. So in summary, let us go through quickly so that it will be helpful. Fire protection of buildings addresses all aspects of fire safety and consists of a combination of active and passive measures. Active fire protection devices require manual, mechanical or electrical power for their operation. Passive fire protection does not require any external power. This chapter deals with one aspect of passive fire protection, fire containment. This type of passive fire protection includes test methods to evaluate the performance of interior and exterior assemblies and structural members when exposed to fully developed fire conditions, as well as measures needed to provide a safe separation distance from exterior fire sources. Fully developed post-flashover fires are contained to the enclosed space of origin by using fire-resistive separating and load-bearing building elements. The fire resistance of a building element is determined through furnace testing. The element is exposed to the furnace environment, which follows a standard temperature time curve Structural elements are subject to their design load during the fire test. Steel frame floor assemblies may have to be tested under restrained conditions. Endpoint criteria are based on heat transmission and integrity for separating elements and load bearing capacity for structural members. North American fire resistance furnace test standards may require that the test specimen be subjected to a host stream test after the fire test is terminated. Experimental variables that affect the severity and results of a fire resistance furnace test are discussed. So, the most commonly used ASTM, NFPA, UL, ULC, ISO and IMO fire resistance furnace test standards are briefly described in this particular chapter. So, basically, if you go through the summary of each chapter, you will have a good understanding of the contents which are found in that particular chapter. So chapter 6 covers fundamentals of fire detection. Here it deals with the fire signatures and simplified fire developments. So fire signature, characteristics of fire signatures and aerosol signatures, energy release signatures. So in energy release signatures, there are two types of energy release signatures: radiative and convective energy release. So radiative energy release signatures, you have different type of wavelengths. Radiation is emitted across a wide range of wavelengths. This is an important concept. Ultraviolet 0.1 to 0.35 nanometers, visible length 0.35 to 0.75 nanometers, infrared 0.75 to 22 nanometers. So this is an important points for your examination. They might ask what is the wavelength of ultraviolet, something like that. You have gas signatures, multiple signature detection, other fire signatures. So here summary, this is a small chapter. A variety of technologies exist for detecting the products of combustion generated at different stages of fire growth and spread. These technologies are based on detecting one or more unique fire signatures and have been growing in sophistication as the fire community becomes more adept at measuring fire and its effects. So see, basically we are going through these chapters thoroughly, and we are not discussing here in detail about the concepts of those particular definitions. Just I am showing you what are the main topics that you have to concentrate on for your examination. Chapter 7 related to the theory of fire extinguishment. Here so many things are there. As you can see, mechanisms for affecting the combustion process: extinguishment with water, extinguishment with foam, extinguishment with water mist, extinguishment with inert gases, extinguishment with halocarbon agents, extinguishment with dry chemical agents, and special cases of extinguishment. So theory of fire extinguishment, we cover all these particular topics in this chapter. So combustion, flaming and pyrolysis, again they have given related to these topics we already discussed in our previous slides. The term combustion usually refers to an exothermic or heat producing chemical reaction between some substance and oxygen, and a flame is a gaseous oxidation reaction that occurs in a region of space much hotter than its surroundings and generally emits light. If chemical decomposition occurs, the process is called pyrolysis. Pyrolysis is also an important concept you have to go through. Extinguishment can be accomplished by cooling either the gaseous combustion zone or the solid or liquid combustible. Here we have extinguishment with water. We have characteristics of water. Water as an extinguishment agent. The two most common means of applying water are by solid stream or spray from a hose and spray from automatic sprinklers. So extinguishment of water, extinguishment with aqueous film forming foam. Aqueous foam agents are principally used for fighting flammable liquid fires. Important concept. Extinguishment with water mist. You have fixed installation in which a fine mist is used to inert a compartment in which a fire may occur, perhaps in a concealed and unpredictable location. You have a portable extinguisher using a fine spray or mist. We have fixed spray nozzles positions around or above the site of an anticipated fire. So we are extinguishing fire with water mist, and the application mechanisms they have mentioned here. Water mist effectiveness depends upon the momentum and direction of the spray related to the fire, droplet size, and the compartment geometry and size, and the size and location of openings. Extinguishment with inert gases, the solid form of carbon dioxide commonly known as dry ice. Extinguishment with halocarbons, and this table is very important. Physical properties and chemical formulas of 3 halogen extinguishing agents. Maybe they might ask a question from this as well. So we have extinguishment with the dry chemical agents. This also an important table which you need to go through. Maybe they might ask the chemical name or formula or the popular name of this particular chemical name. So for example, you have sodium bicarbonate, so the formula will be NaHCO3. Popular name is baking soda. So you might get a question from this table as well in your examination. You have special cases of extinguishment like metal fires, chemical fires, and you have one more table here, extinguishing agent for metal fires. So agent like powders, liquids, and gases, main ingredients, they have given the formula, used on which metals. So you just go through this table as well. So basically there are 3 tables which are most important in this particular chapter. Table 2.7.3, which deals with physical properties and chemical formulas of 3 halon extinguishing agents, and you have dry chemical agents, chemical name, formula, and popular name, and one more table related to the extinguishing agents for metal fires. So summary just will go through since it is very small. The fundamentals of combustion science which related to fire extinguishment are briefly reviewed, and references are provided to more detailed treatments. Limits of flammability are discussed. Chemical chain reactions and the possibility of inhibiting these reactions are reviewed. Details of how water extinguishes a fire or a burning solid are presented. The role of aqueous forms in fighting flammable liquid fires is discussed in terms of extinguishment mechanism. Discussion is provided of extinguishment by mists, by inert gases, by halocarbon agents, and by dry chemical agents. Metal fires and chemical fires are mentioned as examples of special extinguishment situations. So basically this chapter is related to the extinguishment with water and other related things such as water mist and dry chemical agents. So chapter 8 is the final chapter in section 2. As I told you, this section covers the basics of fire and fire science. So most of the definitions you might find here. So basically from this chapter there will be 10 questions, or 10% of the questions will come. So you have to be thoroughly quick in identifying the topics from this section 2. So final chapter will be chapter 8, explosions. Explosion would be a sudden rapid release of energy that produces potentially damaging pressures. Here in this chapter you can see the contents, fundamental explosion principles, types of explosions, and the key terms they have mentioned here. Basically key terms maybe here they mentioned, for example deflagration. Maybe you might find somewhere else in other sections as well. So you need to have a good idea on the chapter contents basically. So here they have mentioned peak pressure, energy, and energy release durations. They have given so many things. Blast waves, what does it mean, and how they behave, and so on. And we have various things to discuss, like types of explosions, flammable gas and vapor deflagrations, gas detonation. A detonation is an explosion in which the flame propagates at supersonic speeds through the unburned fuel. Okay. So combustible dust deflagrations. You have some table here related to explosibility data for representative powders and dust. Chemical reaction explosions. Examples of chemical reaction explosions. Here we don't have much topics to discuss. Just we'll go through the summary and we'll close this session. An overview of explosion fundamentals is provided in terms of the relationship between peak pressure and energy release magnitude and duration for various types of explosions. Ideal blast wave propagation and scaling relations are also discussed, along with a brief summary of primary and secondary fragmentation effects. The following specific types of explosions are briefly described: flammable gas and vapor deflagrations, gas detonations, combustible dust deflagrations, chemical reaction explosions, steam explosions, and vapor cloud explosions. So we have completed our section 2, which is the basics of fire and fire science. So I hope you are learning a bit from my video series. So we shall meet in our next session with some other section from the handbook. Until then, bye. Thank you so much for watching my YouTube videos. If you did not subscribe my channel, please subscribe so that you can benefit and you can share it with others who wants to learn about fire protection systems. Thank you once again. Bye.